the state? What are your preferences? The problem is that this would give Alice an incentive to say that state 2 is the state, even though state 1 is the actual state. Now, to see that, notice that in both state 1 and state 2, Alice prefers gas to oil. You see in state 1, Alice puts gas above oil, and in state 2, Alice puts gas above oil. And she knows that if the authority thinks that state 2 is the actual state, the authority will choose gas, which she prefers to oil. So she's going to say state 2, even if state 1 is the actual state. Bob is going to do just the opposite. He has the incentive always to say state 1, because he always prefers oil to gas. Notice that in state 1, Bob prefers oil to gas, and in state 2, Bob prefers oil to gas. So what will happen if the authority goes to Alice and Bob and says, what is the state? Well, Alice will say state 2, Bob will say state 1, and the authority will have no idea what the actual state is. So that mechanism won't work. It's too naive. Well, what mechanism will work? And I wouldn't be showing you this example unless there happened to be a mechanism that worked, and here's one that does. It's given by this little table, and probably many of you have seen some game theory. This can be thought of as a game played between Alice and Bob, where Alice chooses rows, those are her choices, and Bob chooses columns. So Alice can choose top or bottom row, Bob can choose left or right column, and the outcome is just determined by the intersection of their choices. So if Alice chooses the bottom row and Bob chooses the right column, the outcome will be gas. And I claim that this mechanism will solve the problem. That is, it will result in oil in state 1 and gas in state 2. Let's see why that's so. Let's imagine that state 1 is the actual state, and let's see what Alice and Bob would do in state 1. Well, if Alice anticipates that Bob will play the left column, then Alice will want to choose the top row, because if she chooses top, she gets oil. If she chooses bottom, she gets nuclear power. And notice that in state 1, Alice prefers oil to nuclear power, so she will indeed choose the top row if she thinks Bob is going to go left. Furthermore, Bob will choose left, or at least he has a strong incentive to go left, because regardless of what Alice does, Bob is better off going left. If Alice chooses the top row and Bob goes left, he gets oil. If he goes right, he gets coal. But notice that in state 1, Bob prefers oil to coal. If Alice chooses the bottom row, if Bob goes left, he gets nuclear power. If he goes right, he gets gas. But notice that Bob prefers nuclear power to gas. So in both cases, he will go left. So in the language of game theory, Alice choosing top, Bob going left is a Nash equilibrium. Neither player has an incentive to deviate from their choice. And in fact, it's not hard to verify that Alice playing top, Bob playing left is the only Nash equilibrium in state 1. So it's a good prediction of what will actually happen if Alice and Bob play this game, and if Alice and Bob are capable of choosing in a way that advances their own personal objectives. But notice that if Alice chooses top and Bob goes left, we get oil, which is the right choice in state 1. So we've implemented the right choice in state 1. Well, I could go through the analysis